Hey, okay, so we are in Unit 6 and we are finally going to learn about integration. So super cool. And the first way we're going to start looking at integration is by adding up things that could approximate what an area is going to be under a curve to the x-axis. All right, so we're going to talk about Riemann sums and how to know if a Riemann sum is an over or under estimation of what the actual area is. So that's always important, just like how we talked about tangent lines were over or under depending on the concavity. We're also going to have some different scenarios where Riemann sums can be over and under. So if I gave you this right here, this is a curve, okay? And I dropped from here from 0 to 2. So I dropped down at 2 and 0 and then went over along that x-axis. And I asked you, what do you think that area is? Do you think that you could try to identify what that area is just by kind of estimating? So I want you to try that. Go ahead and pause me. See if you can estimate. And then see if you get, after you unpause me, see if you get around 4. That's basically what an integration is going to do. It's going to try to find this whole area between a curve and the x-axis, between two different x values. So we're going to do that first by the approximation using Riemann sums, okay? And here you can learn about who it was named after. So first thing that we're going to do is talk about a left or a right Riemann sum. So a left means come from the left, and a right means to come from the right. Okay, so it's talking about I'm either going to come from the right or I'm going to come from the left. So if I'm looking at this right here and I want a left Riemann sum over 0 to 2, well, I know I'm looking between 0 and 2. I cannot go outside of those bounds. So if I'm left, then I'm going to start over here. Oh my goodness. I'm so sorry. I'm sorry. So if I come from the left, I have to start over here at the left, okay? Whereas here, 0 to 2, if I come from the right, then I have to start over here from the right. So I go to where I touch the curve on the left, and then same thing here. I'm going to touch the curve on the left. I'm going to touch the curve from the left, touch the curve from the left. So, and then I can drop down. I call it like my bars, my cell bars. And then I'm going to find the area in all 4 of those rectangles. Here, I'm going to go touch the curve and go to the right. Touch the curve, go to the right. Touch the curve, go to the right, and touch the curve, go to the right. And then I can drop down all my bars and find this area. Now this clearly is an over approximation, and this clearly is an under approximation of what the actual area would be. So let's see. If I was to go calculate this area, see if you can go ahead. So this is a height of 0 times 1/2. This is a height of, let's see, I'm plugging it into x cubed. So that's 1/2 cubed for that height times the base, which is 1/2. Plus, this is a 1 cubed times the base of 1/2. Plus, this would be the 1.5 cubed, or 3/2 cubed, times the base of 1/2. And when I go to calculate that, I can see that that's 2.25. So here, let's look at the right. Now I have the 1/2 cubed times the base of 1/2, plus the 1 cubed times the base, plus that 3/2 cubed times the base, and then this one is the 2 cubed times the base. And I want you to look, and you can see that these three pieces are in common. The difference is whether or not I came from the left or came from the right of that other fourth piece. So when I go ahead and calculate all of these, I get 6.25. So we know that the exact area is somewhere between those two. And that's really hard, like that's a huge kind of margin of error, okay? But we can get more precise and we'll talk about that. So let's just talk about when we were over and when we were under. So when the graph is increasing, so when f of x, if this is my f of x, okay, graph, when f of x is increasing, then the left Riemann sum is an underestimation. And when this graph, this f of x graph, again is increasing, then we know the right Riemann sum is an overestimation. So what if the graph was decreasing? What would happen? Well, if I came from the left now, I would be over. And if I came from the right, I would be under. So this is vice versa for decreasing functions. Okay? All right, so the next two we're going to look at are what are called the midpoint and the trapezoidal. So the midpoint means I go right in the middle of the two, and that's where I touch the function at. And then instead of going left or right, I go out and down, like from the middle, out and down. So I go out, and then I come down. Out, and then I come down. Out, and down and down. Out, down and down. So here, this midpoint, I'm going to find the middle of this guy. So that's what? 1/4, 0.25 cubed. Still times a base, though, here of 1/2. This would be 0.75 cubed times the base of 1/2 plus 1.25 cubed times the base of 1/2 plus 1.75 cubed times the base of 1/2. So I'm taking the height going on times the base. And this gives me an area of 3.875. And that definitely looks like we're more exact. Okay, so that's looking a lot better. Let's learn one more, and then we're going to talk about over and estimation again. This is called the trapezoidal sum. So a lot of times people forget what a trapezoid is. So the trapezoid kind of looks like this, and a lot of times you can see it's like a rectangle and then two triangles. So the area here of the trapezoid is this base 1 and base 2. We add them together and we average them. So we average out the bases and then multiply times the height. So for our trapezoid, we kind of have to take this and lean it on its side. So if I was to kind of take that piece and look at it, it would look like this. So this is my base 1, my base 2, and then I have the height. This is my height. So we're going to find the area of the trapezoid using those four trapezoids, the area of under the curve using those four trapezoids. Okay, so let's try that. So this is a little bit more writing, so I'm going to probably take a couple of lines, okay? But I'm going to take base 1 plus base 2, so that's 0 cubed plus 0.5 cubed, average them out, and multiply times my height of 1/2. Plus this base, 0.5 cubed, plus this base, 1 cubed, average them out, and multiply by my height of 1/2. We have this one, 1 cubed, plus 1.5 cubed, averaged out, times my base, and then the last one, 1.5 cubed, plus 2 cubed, averaged out, times my base of 1/2. And you can kind of see what you get if you want to plug all that in. I got 4.25. All right, so with midpoint and trapezoidal, instead of just the increasing or the decreasing, because still look, if I am decreasing, midpoint's still kind of splitting, right? And the trapezoidal is also doing some things. So the increasing or the decreasing don't tell me the over or underestimation for midpoint and trapezoidal. What tells me the over and the under here is concavity, just like with tangent lines, okay? So when we are concave up, as you can see, both of these guys are concave up, then the midpoint is an underestimation, not by a lot. And here, when we're concave up, the trapezoidal is an overestimation. So what do you think happens when we're concave down? Yeah, they get flip-flopped, okay? So vice versa for concave down. So why don't you guys, I would, if I was you, kind of take a second and make a flashcard or a little review about these 4 concepts. When is a left and under? When is a left and over? When is a right and under? When is a right and over? Same thing for trapezoidal and same thing for midpoint. Okay, so I would just take a second if you want to pause and kind of get that organized so that you can remember those things as we move forward. But all of these are going to be approximations. What gives us this actual exact area is called the integral. So the integral here is basically you're taking an infinite amount of Riemann sums. So you're making that width kind of go to 0, and you're making instantaneous moments, and you have an infinite amount of them from A to B. That's what this is saying. This integral is telling you that you are summing. Okay, that's what it's kind of telling you to do. But you're summing infinite amounts of pieces between x equals a and x equals b kind of thing. So that's what an integral is kind of doing. Super, super cool. That's like instantaneous area. Okay, so this is one of my favorite jokes. It says, you're like, oh yeah, I'm doing good. Look at me. I'm getting really close to that area. Oh yeah. Versus the guy she told you not to worry about, which is far more superior. Okay, anyway. So let's look at this next one. A lot of times we're going to just see a table. So here, this is wanting me to find the area under the velocity, and here's some of the velocity things going on with 4 subintervals. So kind of have 1, 2, 3, 4 subintervals. And I want to do the 2 things. I want to do a right Riemann sum and a left Riemann sum. So if you remember, if we are doing a right Riemann sum, then we have to come and we start at the right and we move that way. Okay, so here on my right, I'm going to take my output of 10 and multiply by the change from 9 to 12. So that was by 3. Then I'm going to take this guy, which is a 9, and multiply by the change, which again was 3. And then I'm going to take this guy Oops, sorry. I said 9. That was 15. Oops. Okay. 15, there we go, times the change of 3, plus this guy, which the output, that's what we're looking at, is the 20, times the change of 3, plus this guy, negative 15, times the change of 3. So this is kind of the base times the height going on for all of these. So then we can put them all together. 45. Let's see. When I simplified my right Riemann sum, I got 90. Oh yeah, look, those cancel. How sweet. Okay, so how is B different? Now we are coming from the left. So we start here and go this way. So on A, this last guy was left off because it was at the end that we didn't include the height of. Now this one will be left off because we're coming from the left. So now I have the 10 times the change of the 3 plus the negative 15 times the change of the 3 plus the 20 times the change of the 3 plus the 15 times the change of the 3. And for that one, look at that. I got 90 as well. We think that's maybe getting pretty dang close to what it should be. But remember, that's you, not the other guy. All right. But I just wanted you to kind of see in a table how it's a little bit easier, in my opinion, because you already have the outputs, you have the heights. Okay, so this one's a little bit different. This is saying I want the absolute value. So I'm going to go ahead and just take the absolute value, and that's the only one that I have to switch. And then it only wants now 2 subintervals, so I need to break this into 2 subintervals. And it wants to use the midpoint. So here's the first one I'm going to use, and here is the second one I'm going to use, and I do the midpoint of that. So this midpoint is 15, but the change is 6. This midpoint is also 15, and the change is the 6. Okay. Okay, I would like for you guys to try this one on your own. Go ahead and pause me and make sure you can get 64. If you don't get 64, then you need to ask me in class. Okay, so let's look at the next one. This one again wants the absolute value of velocity. So I'm going to go look through and make absolute value wherever I need. This one wants a 4 subinterval. 1, 2, 3, 4. And now I'm going to do a trapezoidal. So in trapezoidal, I'm going to average the 2 bases, multiply by the height. Sorry. Okay, so that height now is 4. Plus, average the 2 bases, and multiply by the height. Okay, plus, average the 2 bases, multiply by the height, so that's difference of 4, plus, average the 2 bases, and multiply, average the 2 bases, multiply by the height, average the 2 bases, multiply by the height. And then what's nice on these is when you're doing it, all of these cancel to 2. So you could like pull a 2 out and do 12 plus 20 plus 20 plus 8 plus 8 plus 12 plus 12 plus 10. So you can start to see patterns and number sense as you're doing these. And I got 204. Okay. So what I would like you to try is this little summary going on. It wants you to tell me which is going to be bigger here. Here, there's the directions. Which one is bigger? If A is bigger or B is bigger, okay? And then tell me why into the third column. So I want you to try and pause me and then unpause when you're ready, and we'll go over and discuss it. All right, so in here, if we're looking at right or trapezoidal, okay, so with the right, I can see that I am increasing, so right is an over approximation. A trapezoidal, it says I'm concave down, so a trapezoidal is an under approximation. So column A is greater. The right Riemann sum is the over approximation, and the trapezoidal sum is the under approximation. Okay, next one. If you didn't pause me for all of them, then pause me now. Otherwise, go ahead and flow. So if we are decreasing and I come from the right, then I know that this is an under. And here's our beautiful, the other guy, the exact. Okay, so column B is greater than column A. And I'm okay if you just tell me this, like I kind of explained it here. Okay. All right, next one. Increasing, and we are concave up. Okay, so we know, oh, trapezoidal is over. Trapezoidal over. Okay, so we got to look at this in a little bit more detail. So let's say that I have this and I only took one big interval. Then all of that's going to be an overestimation. Now let's say I have it, but I'm going to split it into two intervals. Now I have decreased the amount that I am over approximation. So while these are both over approximation, the more intervals I do, the closer I am to being exact and not being so far off in my error. So A here is going to be greater than B. Okay. Decreasing from the left is an over. Concave up, ooh, that's also an over. But which one has the bigger over? Here is from the left. And here is the trapezoidal. And I can see the left definitely over approximates way more than the trapezoidal. So B is greater than A. F of X is increasing and concave down. So if we are increasing, then the right, where am I at? Increasing right. Both of these are over. But remember, as I increase how many I'm doing, I'm not quite as much over. I'm getting closer. This is a better approximation when I have more than when I have less. So these are both over, but this one's not as bad. So A is greater than B. All right, go ahead and see if you can try this one. You need to do a matching and see how you do. Pause me, and then when you're ready, unpause. So I got C, B, D, and A. Okay. If you have questions with those, let me know. Okay, you can try this one on your own as well. See if you get D. And I want you to try this one on your own and see if you get E. And try this one on your own and see if you get A. Then we're going to do this one together in class. And I'm going to break this into two different sections for day one, so we're going to stop here for now. I'll see you in a little bit.